Hello again, all my friends. This is now our 9th volume video. Miss Cherio, why are you laughing?
No, I'm not. I'm just happy to be here.
She's just happy to be here. All right, I gotta correct myself. This is our 9th measurement video, and we are now looking at volume, this impeding word that we've never talked about, but we will for today. And it's actually volume of our three-dimensional shapes. What kind of three-dimensional shapes do we have, Miss Cherio?
We have a cube,
You draw us a cube?
right? So we can have a cube in here. Remember how it looked like? Two squares. They're a little crooked, but it works.
That's okay. A little crooked.
And also you have this one. Oh, I forgot to tell you. This one has another name. Do you know what another name is for the rectangular prism?
Is it a rectangular base prism?
No.
Oh, maybe not.
That is a cuboid.
Cuboid.
Yes.
That
This
sounds.
This is also called a cuboid. Yes.
Indeed. Now, we're not just talking about these shapes with straight edges. We're also talking about shapes with curved edges. So, for example, something that we see in science class a lot. Kind of looks like that. Curved edge at the bottom and top. Now, that's a beaker, right? We can find the volume of the beaker. Sometimes it says it on the side for us, but if we really want to know how much it contains, we're going to look that up. And as always, happy to be here. It is Mr. Benjamin. And
it's Mrs. Stereo. Mrs. T.
Fantastic. Okay, let's continue. So before we go any further, we're going to go over our learning goals. Learning goals for this video on volume. Recognize and label 3D shapes. So we kind of talked about with our nets previously, but we do need to make sure that we know what shape we are using in each question because the formula we use to find the volume might change. After we've recognized that shape, we can then calculate the volume, which is represented with a V, by using the given formulas.
Important.
Very important. So we're going to look at our steps. Little staircase, see? Steps to solving. Step number 1 is identify. Like we just said, you have to identify what 3D shape you are using and label the length, width, and height. Now this is for our straight edge shapes. So this would be for our cube, C-U-B-E, and our cuboid.
Or rectangular prism.
Or rectangular prism.
I mean, yeah.
Yeah, rectangular prism. Don't confuse me, Miss Terry,
No.
okay? I have enough problems confusing myself, all right?
All right.
So, once we have established our length, our width, and our height, I know we've talked about those terms already. Once we've found out what those are, we can then use the equation for volume, which is length times width times height, to calculate the volume of the shape. Now what we did was we had a box of cereal. Now I'm not going to tell you what kind of cereal it was, but we took a box of cereal and we measured it and we found these measurements. We found that our length of the box was 5 centimeters. Our width of the box was 2 centimeters. And the height of this box was 8 centimeters.
Now what it will be used for is just to label this. So maybe let's label this. So this is the length. Right? Okay, this one was
The width.
the width, okay, and this one was the
Height.
height.
Very good.
And then, I don't know if you noticed, but length, and this one is the width, and this one is the length, right? Look, if we take these two here, do you remember the formula? What
We've seen
formula
that
was
before, haven't we? Is it perimeter?
So that will be
No.
no, this is the area, right? So you can find the area of this base and you can just times the height. That is this. That's one way of doing it.
Very good.
Okay? So now maybe you can explain the way you were doing it, but this will be a short way to do this. Now, if you are not comfortable by doing that, you can go with what you were saying. Length times width times height, right?
So we're going to write it out both ways. So volume, as Mr. Terry was saying, is equal to the area of the base times the height. And area, as we know, is equal to an object's length times its width. And we still have to carry over that h times height.
Right.
So we can now put these values in, right?
That's good.
So, Mr. Terry, what's my length?
So your length is 5 centimeters.
5 centimeters. My width?
Times 2.
2 centimeters.
And times 8.
And 8 centimeters. Now if we do that in our heads, 5 times 2 gives us 10, times 8 gives us 80. 80 what though?
That will be centimeter times centimeter times centimeter. That will give you cube centimeters.
Centimeters cubed, not centimeters squared, not centimeters by itself, none of
no.
those. We don't want those. We want centimeters cubed.
So that's the volume.
That's the
yes.
volume.
So now what will be your step 3?
Step 3. Step 3 is to state the volume with the full sentence. So, now I'm going to change that color. I want white. The volume of our box of cereal is delicious. Nope, I'm not going to write that.
But it is.
Is, oh, come on. That S looks horrible.
Is 80.
80 centimeters cubed. Or
Excellent.
80 cubed centimeters.
Yes, perfect.
Very good.
That's
Now,
good though. Now, you see volume, the volume we can see on liquids. And also we can measure the volume in solids. So when we are measuring the volume in liquids, we have different units. So for liquids, we measure the volume in milliliters or liters. When we measure the volume in solids, we have centimeter cube, right? Or meters cubed, or depends. It depends what the unit says on the measurement that
could
is
be
labeled.
nanometers, could be kilometers,
But
which would be really,
it
really
has-
big
it
and
has
scary.
To be, but if its volume is also, it also has to be cubed.
Mm-hmm.
Okay, cubed. All right. So how do you measure liquids? Liquids are usually in containers, and these containers have water or juice or whatever
Or blood.
liquid that it is. So that is how you have seen the beakers at school, that it has this measurement, right? So we're going to measure the liquids by looking at the scale. Now for the solids, is if you have a can of Coke, right?
Or of cola.
Or
Either
cola.
way.
So if you want to actually measure the volume that is inside, right, you have to calculate the volume of the container that contains the liquid.
That's right.
So in here, this one, what shape is this, Mr. Benjamin? That's the cylinder, right?
Well, I know because it's already written down. It's
Yeah,
a
it's
cylinder.
written down. That's a cylinder, right? So now, tell me, going back here, right, the liquids. So we're going to have examples of liquids. So that's water. What else can be a liquid?
Juice.
Right? What else can it be?
Cola.
Cola, okay. So in here for solids, three-dimensional solids, you can have a cube. You can have a prism. You can have pyramids.
Mm-hmm. And we're probably not going to be able to see all that, so maybe write it on this side here.
Yeah, so maybe it's, there you go. Pyramids, all right? So those are the solids. And the volume is going to be, again, the units for the volume should be, for solids, should be cubic centimeters, cubic meters, and the liquids, again, milliliters or liters. I think that's all for that, right?
I think so.
Okay, and then...
Did we say what volume actually is? I don't think we mentioned that yet. We should probably mention that.
we haven't said that. Okay, so maybe I should go back again.
Get another
So
space there.
yeah, so volume is the amount of space that a shape occupies. Okay, so this will be volume. That is your definition of volume. All right?
Alrighty, let's get back to our cylinder. Now, the volume of a cylinder, this is going to be a little strange. It's going to seem like a really long equation, but it's not really. Volume of a cylinder is equal to pi r squared times height. Pi r squared, I think we've seen that before.
Right, and I think it's the same principle. Do you see here? Don't you have two? What are these, Mr. Benjamin? Two circles, right?
Mm-hmm.
On top and at the bottom.
Yep, the base and the top.
So and then the
I'm
base
just
is
going to draw
the
it in.
circle, right? Yeah.
See, that's where it would be. So we're going to take that, which is the area of the circle, and multiply it by the height.
Yes, that's all. That's very easy, though.
And most of these values are known, except for right now we don't know our height and our radius. So we're going to say the radius of this can,
It can be, let's say that's 4 centimeters.
4 centimeters. And the height of our can,
Let's say that is 10.
10 centimeters. So we're going to fill in our values now. Volume is equal to 3.14 for pi times 4 centimeters squared times the height, which is 10. So according to BEDMAS, we have to do this value first. So 3.14, 4 squared should be 16, times 16, I'll put an X there, and times 10.
Okay, just one little thing that I wanted to stress in here, because look, some of you are telling me that 4 square, guys, is not 2 times 4
No.
or 4 plus 4. This is 4 times
4.
4.
So you know what we should do? We should probably write
Always.
that out.
Yes.
Let's do that really quick. Not saying I made a mistake, which I didn't. Times 4 squared.
Square, which is
Times.
4, yeah.
What was the height?
Times the
10.
height, 10, yeah.
Equals 3.14 times bracket 4 times 4.
Yes.
And that is times
Times
10.
10.
So now we can do all that. 3.14 times 16, because 4 times 4 is 16. And we
Right.
had to do that first because it was in brackets. Times 10.
Times 10.
So
Now
now
you
we're going to
can
work this
multiply
out. So it's going to be 160 times 3.14. And I was doing a quick calculation in my head. It's going to be around 480 something, but it's going to be different than
Times
that.
14, times what?
Times 14.
Whoa.
Oh, Miss Terry, give me the calculator.
Okay,
So we've got 3.14 times 160.
No, yes.
502.4. Okay, I was off by a couple. That's fine. 502.4. That's a 0. That's
And the
a
units
2,
are
502.4. And the units for this, now, there's two ways of writing it, right?
yeah, no, that's fine, because in here is you have centimeters
Mhm.
and centimeters and centimeters, right? So the 314 does not have units.
Nope.
But these measurements have.
That's right.
Centimeters, centimeters, and centimeters. That
Gives
is
you
what?
centimeters cubed.
Right.
And if we were considering the liquid inside of it, we would say
We will say that is 502 milliliters.
milliliters
0.4
instead.
milliliters.
But it's the same thing.
It's the same thing. So 502.4 milliliters of liquid of
Mm-hmm.
Coke.
Of cola, not Coke.
Of cola,
we are
sorry.
not taking any brand names. We're just saying it's cola.
Sorry. Okay, point. I don't
So-
know
Yeah, it's hard to see.
dot.
There it is.
Yeah, good.
So what we're going to do is we're going to try this. So we want you to take either a box of cereal or some sort of can, some sort of liquid beverage from your house.
Have a can of juice.
Can of juice if you have juice in your cans, or cereal. Cereal. Why so cereal? Ha 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 ha.
Oh,
Or can of whatever. Can. Whatever you got. And find the volume. You think you can have that done by tomorrow?
Okay, try to practice. Try to do it. Just try to figure it out. We don't want you to overwork.
Don't go crazy.
But yeah.
But
if
give it a
you-
try.
Just watch the video and have the main concept. And if you would like to do that, please bring the calculations.
And
tomorrow.
remember, it's okay to make mistakes. That's how we learn.
Yeah.
And I think that's it. I'm going to say thank you.
Oh, tomorrow we have a quiz.
No, they would have already had the quiz today.
No, they didn't.
Yeah, this video's ahead.
This video is ahead. Oh.
We're getting confused on time. Don't worry.
Oh yeah.
Thank you. We should really use a different color than purple. Let's make a different color.
I can't believe I never thought that we were ahead. Yeah.
Yellow? Is this a nice yellow?
Okay, good. Yeah,
Oh, I
that's
like
awesome.
that. It's very Easter-like.
Right. It is.
Okay. Bye. Bye now.
Thanks.